Welcome back for another training session on DSSG. I'm Davis Montenegro, the creator of OpenDSSG, and today I want to talk about the user's journey through OpenDSS. So OpenDSS is a scripting language that allows us to describe the system and the actions and interactions that are going on inside it. However, normally when a user tries to start, he has two ways. One is jumping directly into the scripting or going into OpenDSSG to try to learn the basics and get informed on what are the best way to use the software. However, after a while, when the user feels comfortable enough with the environment, he decides to jump into the scripting, which is comfortable and allows users to develop their own applications. However, we were wondering what would be a better way for bringing these two worlds together, providing all the tools needed for doing scripting and graphical stuff under the same roof. After meditating a while, we got to the conclusion that we can provide a new technology for making this a reality. And then is when we're talking about the DSSG Scripting Technology, which we are going to demonstrate through this video. This technology is aiming at harmonizing scripting and graphical environments within electrical analysis software tools. To start with the demonstration, let's start with a simple system. Let's suppose we have the IEEE 13 bus nodes test system, which, as you can see on the screen. The first part will be to bring back the OpenDSS console, which is being part of OpenDSSG forever. However, this time it will look a bit different. So when you open it, you can see that it looks a bit different from what it was before. In the past, it used to be more like an emergency tool in case something in the graphical environment didn't work. You could go and enter the commands, the OpenDSS commands by yourself, and you should be fine. But in this case, we added a lot more functionalities. Among the tools that you will see at the top, there are two that are very interesting. One is called the Distribute Horizontally, which will set up the environment so you will have scripting on one side of the screen, and the other one is going to be the graphical part of the simulation. And we have another command for distributing the screen top to bottom, having the graphical part on top and the scripting on below, which is very convenient when the electrical circuit is distributed horizontally. For this example, we're going to use the left to right, leaving the scripting to the left and the graphical to the right. For the first example, let's connect a couple of buses that are within the system that we are seeing right now. For that, normally we will declare a line that will go between two buses. However, in this case, for the example, we're going to declare that line using OpenDSS commands. So for that, I'll just go to the scripting tool and start typing, but there's something new here. You will see that we have self-complete automation within the scripting. So every time you start typing, OpenDSSG is going to tell you what you're trying to type. You can select one of the options and then hit the tab key to select the option that you want. Many times users don't know what properties are within a certain element because we understand some elements have a lot of options. So you can just right click and try to import a class property. In this case, OpenDSSG will detect the class you are editing and bring you all the different options within, explaining what each one of those properties do. So you just pick the one you want and it's gonna be written on the screen. And then the only thing you need to do is to keep typing. So in this case, we brought the number of faces. We're gonna put 3 faces. And now we're gonna define the buses. The bus can be imported from the graphical environment. One way for doing that is going to the import submenu and select import or get bus by name. So in this case, we know what name do we want. So we can just type it and look for it within a list. We can locate the bus just to confirm that is the one we are looking for. And once we type on it and we select the bus, we can define the connection and send it back to the script. So OpenDSSG is going to write it for me. The other way for doing it is graphically, because many times the name of the buses is not visible, but I know where it's located. So you can just right click, import bus from GUI. And with that, OpenDSSG is going to ask me to select the bus I want to bring in. I'll just draw a little square on it, and boom, it's going to be written in the place I want. You can keep adding properties, just start typing, and OpenDSSG is going to bring you the name of all the different properties that exist in the system. You can import specific properties for the class you're editing, etc. So in this case, we finished declaring our switch. So now we're just gonna execute by typing Control D, and you can see that immediately after that, the system is confirming that the action was done, and we can see that the line was drawn between the two elements, just as we want it to happen. As we can see, since we are in the constructor mode, we can keep editing graphically, so we're not tied to the script or tied to the graphical. In fact, what happened was that every time I was adding a new command and executing it, it will be translated into its graphical equivalent in real time. And that's what, in part, OpenDSSG scripting technology is about. We can also bring help, dynamic help. Just click on the property, right-click, and ask for help. And OpenDSSG will tell you what that property is. Also, you can just select the property, type Ctrl+H, and that will bring the help when you need it. So you don't have to go to another document. Everything is within the scripting platform. As well, it should be. Everything is happening in real time. Let's remove the last line and let's recompile. The recompile is going to bring the system to the beginning as it was saved on the hard drive, and you will see that the graphical environment will refresh, showing the system as it was when we started working on it. So the next step, what we're going to do is define a couple of lines, creating new buses, and etc. So for this, I'm going to just delete these previously entered commands. I'm going to select the bus where I'm going to connect this thing. And there's going to be two lines connected one to each other. It's going to create two new buses, 149 and 152. After that, just select what I want to execute, and that's it. Control D, and boom. It's telling me that it was done, and we can see that the elements we're creating in the graphical equivalent, the schematic. And then we can start, just adjusting things as we want them to look like within the schematic, translating OpenDSS commands into their graphical equivalent in real time. One question that may come from users is, what happens if I have the bus codes for those new buses I want to create? How can I incorporate those? Well, you can very easily. The only thing you need to do is to redirect the script into those bus coordinates to make them count. In this case, for example, I have a script that contains those bus coordinates. I'm going to bring them right now. As you can see here, in this bus coords2.dss, I have bus coordinates for buses 149 and 150. So how can I call those to make them part of this solution of this schematic I'm trying to draw through OpenDSS commands? First, let's recompile everything. And now I'm going to add the command make bus list. Let me delete this. Yeah, make bus list, just to make everything compatible with the new buses. We can calculate voltage basis, but yeah, probably we don't need that. Instead, what we're going to do is redirect to the bus coordinates with the command bus coords2.dss, and now I'm just going to execute. Select what I want, execute, and voila. This is what we get. So now the elements were added to the system, but considering their bus coords. These elements can be edited, so you can still move them around if needed. Of course, the only condition is that you need to be working in constructor mode. The DSSG scripting technology allows you to import graphical elements to the script at any time, and this can be done in real time. For example, right now, I'm editing a new load, defining the buses, the KV, KW, and I would like to link a load shape that already exists in memory to the system. What I'm doing right now is just the typical, just defining the properties, entering the values, some of the commands. We already demonstrated how to bring buses from the GUI or by name. And next, after defining KW, we're going to call the property daily. And we're going to import a load shape that already exists. So for that, I'm going to the submenu import, and I'm going to bring the load shape. This section will open the load shape manager for me to select the load shape that I want to import just by clicking on it, clicking on select, and with that I'm going to write it directly into the script. Now let's try something more interesting. Let's suppose we want to create a new wind generator system within the IEEE 123 bus nodes. So for that, we're going to add a transformer, some behavioral curves, including the wind speed, the performance losses for the wind generator, and some monitors. We do exactly the same that we will do using a normal OpenDSS script and just execute. Once we execute, we can see that the new bus was created, and if we try to highlight the wind generator, we will see that the icon shows up immediately. We can, I'm just removing the names, the bus names to make it more visible, and I'm going to bring the inspector to see the element. So here in the inspector, I can see it graphically, displaying all the properties using the wind generator manager. Here, all these properties were defined using OpenDSS commands using the DSSG Scripting Technology. The interesting thing is that so far we've been translating code into graphical objects, but can we do backwards? Absolutely. And the most interesting thing is that we can do it in real time. But before that, I would like to demonstrate how you can control the whole environment using OpenDSS commands through the OpenDSS console. Let's suppose I want to solve the system using scripting commands. You can do it, but for that, you're going to have to go into simulation mode. Every time you solve the system using the scripting tool, you'll see that it will mark solved at the tools palette and also at the bottom of the DSS scripting. But after bringing the voltage heat map, you'll notice that there's a white color around the wind generator. That's because we haven't defined the voltage basis for that bus since the wind generator works at a different voltage rating. We can solve that just by bringing the voltage basis and then setting the correct voltage basis. We can see that the wind generator has 0.69 kilovolts voltage rating, so we need to add that to the vector voltage basis. We're going to do that here with a comma. We're going to execute. If we try to solve it, still not solved because we need to calculate the voltage basis. We're just going to add a calc voltage basis, execute, and solve using the script. And now it looks more reasonable. So now let's try to do something more interesting. What if we add a daily profile to all the loads in the system and see it progressing, for the day using the real-time simulation tool, including OpenDSSG. For that, first let's set up the simulation. What if from here we can set up the simulation mode, the number of iterations, in this case 1, we're going to go hour by hour, and just in case, let's set up the maximum solution iterations and maximum control iterations, just to make it more, avoid those warnings that we don't like when we're running the simulation. So we execute that, and now we're going to start the real-time simulation tool to go second by second with the simulation. But before that, remember to do the batch edit, load, star, and we're going to assign the default profile to all the loads in the system. And now we're ready to go. So we start the real-time simulation. Here we can see the clock progressing and the voltage changing depending on the hour of the day, representing and following the demand across the system. So we can see how it works. Some parts of the system are definitely reporting a better voltage than others, of course depending on the resources and the demand in that place. Now, as I promised, let's do the opposite. Let's go from the graphical to the script tool. For that, I'm going to highlight all the different loads that we have in the system just to make sure that we know where they are. There are different ways to do this. One of the probably most popular will be to use the inspector. So you just select the area of the elements you want to inspect, and then by right-clicking on an element, you can export its definition back to the scripting, and that's it. So now we have everything that the element has synchronized with OpenDSSG and exported to your script so you can check what is inside and edit it. You can do the same with lines. For example, in this case, I can localize the lines I want to work on, and then just right-click, export the line definition to the script, and that's it. So we have everything that is defined in OpenDSS brought to you so you can start working on those properties at convenience. There are different options within the exporting from the graphical to the scripting. For example, here you can right click and within the export bring all the names of the elements within the inspection window, and that will allow you to work on multiple elements concurrently. So modifying different properties for each one of those at the same time, just for the sake of adjusting things to the way you want them to be adjusted. You can do the same using the navigator as explained in the user's manual, which nowadays is up to date, and you can get all the information you need regarding this technology, including OpenDSSG version 6. There are shortcut keys for some of these functions. You can find those at the menu bar. For example, for bringing in load shape, you can use Ctrl plus L. Just put the cursor on the script where you want it, Ctrl L, and follow the instructions. That should make easy to get access to all the resources that you have around in the active OpenDSSG session. Another tool that users can find in this scripting tool is the use of class templates. This is because many times users don't know what are the basic properties for declaring an element. For that, you can bring class templates. This will start a dialog for the user to select the class he wants to declare from a list, and then OpenDSSG will write a template with all the properties that the user needs as basic for start declaring the element. The first step will be to declare the element's name and then start adding all the different properties that he needs. Of course, this can be extended and expanded to other properties that are of need. It is available for all the different classes. Here you can see it for a line, and you can keep exploring, trying to get these templates in case you don't want how to start with a particular class. Another interesting feature is that the scripting tool can be used for debugging OpenDSS scripts. For instance, we are defining and entering the commands for declaring a new wind generator system within the IEEE 123 node system. As you can see, we can copy and have management of all the different commands, and we have feedback from everything we enter into the system. Now, if I try to run it again, you will see that all the commands that were executed get highlighted. Everything that was executed successfully gets highlighted, and we can see the representation graphically. Now, let's suppose we try to do the same twice. What's going to happen? We're going to get a warning. OpenDSS is telling us, hey, you're trying to redefine an element that was already defined. Do you want to keep going or not? So you can decide if you want to keep going or not. But if you decide to abort, OpenDSSG is going to show you and highlight the line that was giving you trouble. And at the bottom is going to show you what is the problem that is going on with that specific line. This is very useful for finding parts of your script that may be introducing an error into the circuit model. I hope you have enjoyed this tutorial. Thank you.